So in this video we're going to be solving exponential equations. So let's say we have a 200 gram of something radioactive called radon, and 16 days later only 12.5 grams remained. So the question is, what is the half-life? So what is the half-life? Let's calculate that. Well, first let's start writing our half-life formula, which we know is our principal, right? Times 1/2, which represents half-life, t over h, t being the number of days, the time that has passed, and h being the half-life. So let's plug in what we have. M of t is what remains. We started with 200 grams and we're left with, I'm going to write this as 0.5 instead. And we know that 16 days has passed and h is what we're trying to find, the half-life. So let's start solving for h. So first thing I'm going to do is give myself some space here. Let me just write that up there. So if I divide both sides by 200, 12.5 over 200 should give me 0.0625. And I'm left with that. Now what we're going to do that we haven't done before is now apply the logarithm. We're going to apply the logarithm. I'm not saying it's correct. We're going to log both sides. Because right now, from a mathematical standpoint, this side is equal to this side. For a fact, we know that to be true because of this formula, which we are reinforcing. Which means that if I take the log of both sides, I should get the same number as well. And like taking the log of something is always useful, because now I have this exponent up here, which I can use the power law to bring that down here to 16 over h log 0.5 equal to the side still 0.0625. And now all I have to do is isolate this, and well, I can multiply both sides by this h and this will cancel out, and I'll be left with that. Which means I can divide both sides by this log 0.0625, and I'll be left with 16 log 0.5 over log 0.0625. let's do this. 2 to the power of x plus 2 minus 2 to the power of x is equal to 24. So, what can we do here? If we remember our exponential laws, we know that when you have 2 to the power of x times 2 to the power of, say, 2, when you multiply these two, the exponents actually add. So that's how we're going to split this one here. 2 to the power of x times 2 to the power of 2 minus 2 to the power of x is equal to 24. Now I'm going to factor out 2 to the x from this side, and I'm left with 2 squared minus 1 is equal to 24. Now I can just solve for x, which being, 2 to the power of x is equal to 2 squared is 4 minus 1 is 3. I can just divide that side by 3, which should give me 8. And I know 2 to the x is equal to 2 to the 3. X is equal to 3. Easy peasy lemon squeezy. Now, to do or not to do another word problem. Yeah, let's do it. Let's say we have an investment of 2,500. Let's say you wanted to grow at a rate at 4.8%, compounded annually. The question is, how long till it becomes 4,000? So let's put that into our formula. A equals principal times 1 plus interest to the power of n. We know that we want 4,000, and we start with 2,000. 4.8 is actually 0.048 to the power of n. So, let's start solving this. We have, 2,000 on one side, 4,000 the other. Divide that, 4,000 over 2,000. Should be left with this. Oh wait, my mistake. It's 2,500. So it should be 4,000. It should be, 4,000 over 2,500 should be 1.6. 1.6. What am I doing? 1.6, correct. So now let's take the log of both sides. And use the power law to bring down the n here. And now I can isolate n by dividing both sides by this log 1.048. So I'm left with log 1.6. Log 1.048. And you punch this into the calculator, you should get 10.025. And that's how many years it will take if you have 2,500 invested, compounding annually this. 2 to the power of x plus 1 is equal to 3 to the power of x minus 1. And let's try solving this. Try to find the exact value of this. So let's start by taking the log of both sides because I want to bring these exponents out to play. So using the power rule, I'm going to bring this x plus 1 out here. So I should be left with log 2, and same on this side, x minus 1. I should be left with a log 3. So let's go ahead and expand both sides. So I should have x log 2 plus log 2 equals x log 3 minus log 3. And now let's arrange the x's on one side and the non-x's on the other side. So I should have, I'll bring this 3 over to that side. So I'll have log 3 plus log 2, and I'll bring that guy over to this side, x log 3 minus x log 2. And what I'll do is divide. See, now I can actually factor out an x from this side, like so. So I'll be left with log 2. So now I have x here. I can really just do this. X is equal to what is on this side, log 3 plus log 2 divided by what was here, log 3 minus log 2. And there you go. I've successfully taken out the x out of there by bringing them out, expanding, moving them to one side, factoring it out, and isolating it. I have x by itself, and I can punch these into the calculator and get about 4.42. That may have looked complicated, but take your time with it. Practice. Always try to isolate. Try to look for ways to isolate x on its own. And the solution will come. Anyways, that was fun. I guess if you want to try one on your own, let's see what I got.